Okay, so here's our next example. It's the same as the first one. We're just going to kind of build up into a little bit more intense equations. The first ones, it was pretty much solved for us. On these, we actually have to do a little bit of moving around. So I'm going to subtract the 1. So 2 cosine x equals negative 1. Cosine x, if I divide by 2, equals negative 1/2. So we're saying what angle in degrees has the ratio of negative 1/2. Okay, so where cosine is negative 1/2, look at your unit circle. We've got 120 degrees. So I'm going to write that 120 degrees and 240 degrees. Again, we're finding all angles, not just those two, not just the ones from 0 to 360. Okay, if we look at those, are those equally spaced? Like, can I go exactly 180 degrees or a very specific degree and always land on those two angles? Not that I can see. And we know cosine has a period of 360, so that's very rare that you can ever do anything but 360. So my answer is going to be 120 degrees plus 360 n. And 240 degrees plus 360 n. Again, n is any integer. It could be negative or positive, and it's just going to force us to look at all the possibilities, all the coterminal angles. Okay. On our second one, 2 sine alpha plus square root 2 equals 0. Again, we're just going to solve this. And you might be thinking, oh, this is pretty easy. It is. When we get to a little bit more complex solving, it's a little bit more intense, but not bad. Okay. So I subtracted the square root of 2 and then divided it. So I'm looking where sine is square root 2 over 2 negative. Well, I know sine is square root 2 over 2 with the 45-degree angles. If it's negative, all students, so not the first, not the second, so third and fourth. So we're going to get 225 degrees and 315 degrees. So plus 360 n plus 360 n. Okay. Perfect. So let's continue on this same video and let's look at example C. Okay, on C, we're looking at the interval from 0 to 2 pi. Okay, our first one is cosine x equals 2. So it's saying what angle gives me a ratio of 2? Well, let's think about this. Caught another hippie. Okay, let's see. So we know cosine is a ratio of adjacent over hypotenuse. So if we look at this, cosine x equals 2 over 1. We're saying that we have some triangle where the opposite, adjacent is 2 and this is 1. What do we know about that? Well, our hypotenuse can't be bigger than the adjacent. This is not a triangle. So this actually has no solutions. Solutions. I couldn't remember how to spell solutions there for a second. Okay? So that can happen. It does happen that sometimes they give you a situation, a ratio that does not work. So no solutions, not possible. However you want to identify it is no good. Okay. So then let's look at this next one. So 3 tangent squared x plus 1. Okay, I'm going to treat this like I would any other problem. If I had like 3x squared equals 1, first thing I would divide that 3 off. So tangent squared x equals 1/3. Okay, if I had a squared, the way to get rid of a square is a square root. So we're going to square root both sides. So that'd be tangent x equals the square root of 1 over square root of 3. So tangent x equals 1 over square root 3. So tangent x if we rationalize that denominator, is square root 3 over 3. Okay, so from the first video, I found out that square root 3 over 3 is with the 30-degree angles, or pi 6. Okay, so I know tangent, so x has to equal pi 6 for it to be square root 3 over 3. Now I need to find the other one. So I need to find the other one. All students take calculus, and the next positive one is at 7 pi 6. Okay, and if you remember, this was find the interval between 0 and 2 pi. Okay, so if I'm finding between 0 and 2 pi, there's only two answers, or two angles, that are going to give me square root 3 over 2 for tangent. These are going to be my two answers. So this one's a little bit different from the last one because I've got two answers, but I made a mistake. Hopefully you guys spotted it. When I take the square root, what do I need to do? Plus or minus. So I am actually missing two answers because of that square root I had to take the plus or minus. So I've only got the positive. I got to find my negatives. So my negatives are going to be 5 pi 6 and 11 pi 6. So really, there are 4 solutions to this one equation. Again, because of that squared making it plus or minus. Careful on those, they could get you. Okay, so let's look at our next one. And again, guys, if I ever go too fast, just pause the video, take a second. If you ever have questions, email me and I'll always work out individual problems. Okay, this one looks complicated because we have a cosine squared minus cosine. Some of you might want to, divide it by cosine or add the cosine over and divide it off. Okay, if it is a variable, do not divide it out. Okay, if it is a variable, you cannot divide it out because you're dividing out one of your solutions. So first thing I'm going to do is I look at this. If I'm not sure and it's got two of the same, if you tack parentheses on it, for some odd reason it's easier to identify, we could factor out a cosine x. So I'm left with cosine x minus 1 equals 0. We know that when we have two things being multiplied that equal 0, that these two must be 0. So either cosine x equals 0 or cosine x minus 1 equals 0. And we solve for both, just like what we do when we factor or solving quadratics. So cosine is 0. Cosine is our our x value. And again, you guys should have your unit circle. If you look at your unit circle, cosine is 0 at pi halves and 3 pi halves. Okay, so pi halves and 3 pi halves. So there's two answers there. Then if we look at this, cosine x equals 1. So we added that 1 over. So where is cosine 1? Well, that is at 0 radians. Okay. Do we include the 2 pi? In this case we do because we have brackets, meaning those are included. So 2 pi. Any other place? Nope, not that I can see. So my answer is going to be these 4 answers. Okay. And I think I actually have this next one on the next video. I just want to look at this. This is going to be a what if. That's not a what, that's a what. What if it was all solutions? Okay, on this one. What if this was at all solutions? So this is if the solution is interval. What if it was all of them? What could we do with the pi halves and 3 pi halves? How do I get from one to the other? How many degrees? Is it an even degree between them? Okay, so this one we would say pi halves plus pi n, because those are 180 degrees intervals back and forth. Okay, and then this one would have been 0 pi plus 2 pi n. That is if it was all solutions. Interval solutions, you're going to have a list. All solutions, you're going to have plus pi n or plus 2 pi n. Okay, and with this one, if you don't want to do 0 pi, you can just do 0. It's up to you. I go back and forth. Okay, here we go. For the next video, they're going to be a little bit more involved, but we could still do it, okay?